In this video we are going to look at the concentric symbol, its meaning, and why it may be used. In this drawing we can see a shaft, or axle with two ends that have a flat, or key, to be fitted to a pulley, cog, or similar. The datum A is placed on the main axle, but as this is a cylinder as discussed in a previous video, it is the axis of the feature that the datum is related to. At the bottom left of the drawing we can see a control frame. The leader of the control frame is also pointed to a cylindrical feature, meaning it is also referring to the axis of that cylinder. In the frame we can see two circles, one inside the other. This is the symbol for concentric. Something is concentric with something else, when both features, normally circles, have the same center point. Therefore the concentric symbol seeks to control the centers of two circular or cylindrical features, keeping them within a confined limit of distance between them. This is the tolerance. We can now see the same information we just discussed more closely. Looking at the control frame we see that the concentric symbol is followed by a tolerance of 0.1, which for this video we will take as 0.1 mm. And lastly we can see that this is related to datum A. This then is telling us that the two cylinders should be made with no more than a 0.1 mm difference between the two axes, or center point positions. Now let's put a pulley on the end of the shaft. Spinning the shaft with concentric centers we can see the pulley rotates about the center. The two parallel blue lines demonstrate that the pulley does not move from its central position and stays within them. This is an ideal situation for any axle or shaft and the items that may be attached to it. Now let's move the centers away from being concentric. See what happens when the shaft rotates. This is a dramatic movement to illustrate the point, but you can see the pulley moved around a lot, crossing both lines and moving side to side. Now imagine a belt attached to the pulley. It would be continuously stretched and slackened on each rotation. This would most likely damage or destroy the belt very quickly, but the movement of the pulley would also cause vibration. This could shear bolts, damage other equipment on the machine or cause unwanted noise. It may also wear out any motor fitted to it, much faster than optimal running conditions would. You should now see why this is an important control for a designer. Without limiting the amount of difference in an axis of cylinders or centers of circles, a machine's longevity, or mean time between failures, could be severely reduced.